It's just a couple of things unrelated to necessarily the content we've been talking about that I noticed on the homework quiz that I wanted to just clarify or remind us about. So these were like some common mistakes. So they're both involving square roots. So if I have any equation and I square root both sides of this equation, what happens? Plus or minus. I can't count how many people were dropping plus or minuses all over the place. That happened quite a bit. Megan's already saying I did that. That's okay. That's why we're reminding everybody. Like, I get that. That's okay. That happens. What's more concerning to me is when we had something like this. Is this true or false?
False.
False. I saw this far too much. Okay, let me be clear here. The only operations that you know that distribute are multiplication and division. Radicals don't distribute. Exponents don't distribute. Sine, cosine, tangent does not distribute. The only stuff that you know about that distributes, multiplication and division. What is the square root of x squared plus 4? It's just that. There's nothing more you can do to that. That's done. Everybody okay? If you're ever confused and you're wondering, oh, can I do that or not? Like, pick a number. You know, like if I make x equal to 1, that's the square root of 5. Is the square root of 5 the same thing as 3?
No.
No, right? That's a good indicator that it's false. If you're ever not sure, just try plugging in some like relatively easy to deal with numbers. Stay away from 0, and oftentimes 1 if it's like in a multiplication instance. But like pick some easy to deal with numbers and just demonstrate yourself. It's like, oh, no. Those two things are not equal. Okay? If you get them to be equal, you may want to try more than one example just to be sure. But usually you're going to get a case like this where it's like, oh, that ain't right. And you should know right away then that the simplifying you did was not okay. Okay? So that's a good, even if you're not sure, if you're like, can I do this? It feels like something I can do. Just do a quick numerical check for yourself and just make sure. Plug in some numbers and be like, oh, okay, never mind. I didn't just try to do that. You erase that really good. Okay. Again, just, needed to be said. Before we get going with content, are there questions that we have from the homework or just kind of in general? Anybody want to start with any of that? Happy to do that. Even if it's just like, what's the answer to something? Like, that's okay if that's all you want. Okay. If we're okay, I'm okay. You can always change your mind, and we start every class the same way. So if you want to ask again later, that's okay. Or if you're having second thoughts now and have changed your mind, that's okay too. Okay, fair enough. That's fine. Last time we had finished 1.7. Today we're going to do 1.8, or at least start about 1.8. So in 1.8, we're going to be talking about graphical transformations. All right, so help me remember from geometry, what are the 4 types of transformations? Reflection is one. Translation is another. Dilation is another. And the 4th one is rotation. Well done, everybody. Now, rotation, beyond the scope of this class, not something you'll talk about in any high school course, unless it's a rotation that's equivalent to a reflection, which is whatever. And then reflections, we're only going to talk about 2 types of reflections. What 2 types do you suppose it is? Over the x and over the y, right? When we say translation, what do we mean there? Yeah, you're just picking up and moving something to a new location. The size stays the same. The orientation stays the same. Only the location of the object changes, right? Everybody's cool with that? Dilation, what do we mean there? Like a shrink or a stretch, right? Is that going to change other stuff? Say it changes the size for sure, right? Gets bigger or smaller. Can it change the location? Yeah, definitely, right? Okay. Cool. So we're going to now apply this algebraically. To functions. So we call y equals f of x the parent function. And y equals a times f of 1 over c times x minus h plus k, the resultant function. So these coefficients a, c, h, and k are going to control our reflections, translations, and dilations. So let's talk about the reflections first. What happens if A is 0 or C is 0? Notice that those aren't listed as possibilities for reflections. Why not? what's going to happen if a is 0, c is 0? It's a constant function, right? It just zeroes everything out and it just becomes something silly, right? It destroys your function. It just turns into a horizontal line. Not very interesting. Everybody's okay here? Let's look at a little example. So let's say our parent function is negative 3x squared plus 4x minus 1. And we want to reflect across the y-axis. So that's going to imply that c should be negative 1. And then everything else is just going to be a value that doesn't change anything, right? So if we're adding or subtracting, we use zeros. If we're multiplying, we use ones. Everybody's good with that? So my resultant function should be f of 1 over negative 1 of x, or just f of negative x, which would be negative 3 times negative x squared plus 4 times negative x minus 1, or negative 3x squared minus x minus 1. Everybody's cool? What if we wanted to reflect on the x-axis? That would imply the a should be 1, the c, or negative 1, the c would be 1, and the h and k would be zeros. So my resultant function would be negative 1 times f of x. Which would just be 3x squared minus 4x plus 1.
Number 8 is supposed to be negative 4x.
Oh, yeah, thank you. Appreciate that. Anytime I make a silly mistake, you certainly should tell me about myself. I'm not going to act like I was testing you. They're all accidents. I just get going fast. I get excited about the math. And then, you know, I make a mistake on the little details. Okay. The A and the C also can control the dilations. We did C's first, I think, right? So the C coefficient is going to dilate horizontally. So if the absolute value of C is greater than 1, so values of C like 1, 2, 3, 4, 5, or, I'm sorry, not 1, but 1.1, 2, 3, 4, 5, or negative 1.1, negative 2, negative 3, negative 4. Those will be horizontal dilations. So we're stretching horizontally. And if the values of, or the absolute value of C is less than 1, so values like a half, a third, 2/3, 7/8, 0.96, or the negatives of any of those, negative a half, negative third, negative 7/8, those will be horizontal dilation or horizontal shrinks. So we're squishing it in horizontally. And then verticals, stretches and shrinks, same rules, but for A's, right? Why do you think we have the absolute values around these? Why not just say A is greater than 1 and A is less than 1? Connor. Nope. Drew, sorry.
Because like less than 1 is like a decimal. Without the thingies, it could be negative or a decimal.
Yeah, great. So if I just have A is less than 1, that includes things like negative 2, negative 3, negative 4, which are stretches. And it also filters off the reflection piece, right? Because we want to just talk about each of these transformations separately. The reflection separate from the dilation, since the A's and C's control both, right? Great. All right, so let's look at an example here. Vertical stretch by factor of 3. That tells me the A should be 3, and then everything else should be kind of like its null value. So my g of x then should be 3 times f of x. So negative 9x squared plus 12x minus 3. That's easy. Okay. Another example, horizontal shrink by a factor of 1/2. So here, got to be a little bit careful. This is going to be f of 1/1/2, which is just 2x. Oh, fractions. And then we do our function composition. 2x squared is 4x, and then times negative 3 is negative 12x squared. And we have plus 8x minus 1. Is this feeling okay? Yeah. Okay. The last transformation is the translation. So if we have h greater than 0, that's going to shift us right h units. And if it's less than 0, we're going to shift left h units. I guess we put absolute values around both of them. It doesn't really matter. And then the k's are going to shift up and down. Oops. So positive k's go up, negative k's go down. Take our same f of x, and we're going to shift up 4. Tells me that the k is 4, the a must be 1, the c must be 1, and the h must be 0 then. So my g of x is just going to be f of x plus 4. Or negative 3x squared plus 4x plus 3. So here we're going to shift left 1. So that's h should be negative 1, a would be 1, c would be 1, k would be 0. So g of x should be f of x minus a negative 1. Yeah, remember. Bye, Morgan. Have a good time. Shoot some hole-in-ones or something. Like it's easy. Did I tell you the Kim Jong father story last time? So Kim Jong Sr., the former North Korean dictator, like in an interview was talking about his golf game and said he routinely shot multiple holes-in-ones per round, which is either like a fantastic lie or he just has like people hiding in the woods that like go and move his ball into the hole or something. But I thought that was a ridiculous story. Or he's talking about like putt golf or something. I don't know. But even that, hole-in-ones are not, it's not easy. But I guess if he played a lot, it would be the same course over and over again. It'd be a lot easier. I'm not a big putt golfer. Anyways, now we're just getting aside. So f of x plus 1, so negative 3, x plus 1 squared, plus 4 times x plus 1 minus 1. Yo, yucca kebab here. What do I have to do? Foil, yeah, thank you. Yes, Sissy.
Should I go to the bathroom?
Of course. Yeah, no problem. How are we doing so far? Does this all look relatively familiar? Algebra 2E enough? Yeah. All right. Let's do something a little bit sneakier here. Yeah, a little sneakier. So let's say that our parent function here is x squared. And then we do Okay. So here we're doing a vertical shift by 3 and then a vertical stretch by 2. So if I'm taking the vertical shift by 3, tells me k is 3, and then everything else is just its null value. And then the vertical stretch by 2 tells me the a is 2, and everything else is just its like null value. So this is one that we're going to have to do in 2 steps. So after step 1, we get x squared plus 3. And then when we do step 2, we get 2x squared plus 6. You guys see how I notated that? Where I did these as 2 separate steps, not the same thing happening at the same time. Because the order matters. What if we do the stretch first and then the shift second? So there g1 is 2x squared, and g2 would be g1 plus 3. So I get 2x squared plus 3. Oh, not the same. So this leads to the question when we talk about a transformation, what should the order be when we describe these things? If I'm describing multiple transformations going on at the same time, the order in which I'm describing them matters, right? So we need to agree upon an order. So here's what we're going to say. Can't spell across. First thing we're going to describe is the reflection across the y-axis. And then the horizontal stretch or shrink. Then the reflection over the x-axis. And then the vertical stretch or shrink. And then the horizontal translation. And then the vertical translation. All right. So it says describe the transformation in order if f of x is equal to x cubed. And our transform function is 2 times the quantity x plus 1 cubed plus 4. So the key here is going to be identifying the values for A, C, H, and K, which I'm going to get by reading off my function. So this is the general form for any transformation that we quoted earlier, right? This is our resultant function. Since I know my f of x is x cubed, I can rewrite this where my f is now x cubed. Everybody's cool with what I did there? And now I'm going to take my g of x and write that in the same form. Everybody's okay with what I did there? So I can see A is 2, C is 1, H is -1, and K is 4. Everybody's cool with how I decoded that? So I need a minute to just let you process. I see a lot of heads down. If you're like, hey, can you just pause a minute or 30 seconds or something, you can say that. That's okay. I don't mind jogging in place for a minute or two to let you catch up, or just like let something sink in. Some of us are going to be like super comfortable right away, and some of us might be like struggling to keep up, and that's okay. If you're struggling to keep up, just be like, hey, can I have a beat? You know, it's no biggie. All right. So the first thing I consider are the C's, right? C is greater than 0, so I have no reflection across the y-axis. The absolute value of C is equal to 1, so I have no horizontal stretch or shrink. The A is greater than 0, so I have no reflection across the x-axis. The absolute value of A is greater than 1, so I do have a vertical stretch by a factor of 2. My H is less than 0, so I'm going to go left, 1 unit. And my K is greater than 0, so I'm going to go up 4 units. So there's my order of transformations. Notice even if nothing's happening, I'm stating that nothing is happening and why. Is everybody cool with how to do that? That will be the expectation in the homework or on the test or whatever, is that you're able to do that. Do you want to do another of these, or do you think we got it? It's okay? Not a big deal? Okay, McDokays. Let's do a little bit trickier one. So let's give in the parent function here. Let's make this a little pain in the tuchus-y. So, given the parent function 2x squared minus 3, describe the transformation in the proper order. I didn't write that down, but like whenever we say that, we're just going to write them in the order that we just described, even if I don't ask you to or don't remember to ask you to. So we get the resultant function negative 6 times the quantity x plus 2 squared minus 1. Woo! Mr. Kulik, that looks a little trickier there. Okay. So let's, I guess, get started here, right? So G1 is just going to be my parent function. The first thing I want to do is look to see if there is a C going on. So if I look in my resultant function inside the x squared, is there any multiplication going on in there? There's no negative going on the coefficient of the x. So tells me C is positive and the absolute value of C is 1. Okay, so that's step 1 and step 2. The next thing we should be considering is the A. So if I look at the A, what has changed? Multiplied by negative 3, right? So far, so good. Next thing we do is we look for the H's. Certainly have an H there of negative 1, right? Write some notes down there. So that's going to be G2 of x plus 1. Everybody okay there? And we have to end up at negative 1. We're currently at plus 4. What does my k need to be? Negative 10. Oh, let's write it. Let's write it that way. So I have C equals 1, A was equal to negative 3, H is equal to negative 1, and then K was equal to negative 10. Is everybody okay? Do you need a minute? Just say if you do, man. No? Okay, let's write that order then. And I'm abbreviating like crazy here. And just as an aside, if you wanted to check to make sure you've got everything, we're doing that, right? Everybody agree? Sorry guys, I don't know why this has been giving me such a problem. But you can try, if you've identified the values for A, C, H, and K, you can just plug them into f of x and just make sure you get the right g of x back on that kind of a problem. I know these tend to be the trickiest ones right here that we just did, at least in this set, or the ones that students have the hardest time with. I got like one more example to go. Sound good? Yeah, that sounds pretty good to me too. So let's say that we have the following. So let's say we have this function f of x, and we want to graph the transformation. Two times f of x plus 3 minus 1. Ew. What do I do with this? Well, here's going to be the trick. Let me just think for one quick second. I just trying to think real quick if that needs to be C or 1 over C. I just want to think for one quick second. Gosh dang it. I think that's supposed to be a C. Okay. Ugh, come on. All right. So, just looking at my problem, I can identify the values for A, C, H, and K. I can use those to write my function map. And then I can just take my points and translate them using this map. So -2, 0 becomes -5, -1. 0, -2 becomes -3, 3. 2, 0 becomes -1, -1. And then 4, 4 becomes 1, 7. There's -5, -1. There's -3, 3. Oops. Wait a minute. Oh, that should be -5. I missed the negative sign on my 2. Oh boy, we're Look at that. Mr. Kulik, you sly dog, you. Okay. And then -1, -1. And then 1, 7. 1, 2, 3, 4, 5. Something up there. So there's my g of x. Archie. Or Archline, excuse me. You don't like Archie, right? Yes. What do you guys think? The key here, the thing that you need to remember, that map. That's your key to doing one of these, like transform the graph when you're given no function to it. Right? When we don't know what f of x is, that's the trick. You just use that to transform your points and then redraw. You just need some points. What do you guys think? I don't know. I guess, if you say so, Mr. Kulik. That's going to wrap up section 1.8. So you guys should be able to finish up 51 to 6 or 57 to 66. That's the end of our old problem set there, McGee. And I think you guys are a little bit ahead of the 4th hour. Let me look real quick.